Hey, what's up, guys? So today I want to talk about sorting in JavaScript. So let's just start with an array of items. And JavaScript has the method and the array object and the array prototype to sort. So we can simply say something like this, sort, and then we can put it out to the screen. And so let's go ahead and run this. We have to save it, and let's go ahead and run it. And as you can see, it sorted 10, 15, 23. Whoa, that didn't sort. So 10 and then 15. And this is something that I saw earlier with the default sorting in Node. I don't know if it's a bug in Node, but it's basically sorting as if there were strings, even though they're clearly numbers, because if there were strings, they would have the quotes around them. So it's 10, 15, 20. They're sorted as if they are strings. So I'm not sure why it does that. And that makes me not want to trust Node, or maybe the version that I have has a bug. But there's a easy fix for that. We can actually tell it what to use for the sort comparison. So we can say function compare, and we have A and B, and we can return the simple math. Now, the way this works, it's going to return something less than 1, a 0, or a 1. Anything less than 1 means they're out of sequence. If it's a 1, they're in sequence. So for example, if we say, well, I always get that wrong. So if I say this, I just know that if I say A minus B, that's for sorting in ascending manner. So for example, if I say 1 minus 5, it's going to give me -4, which means they are in sequence. In other words, A is less than B, right? So if A is 1 and B is 5, or in this case, 10 is A is 10 and B is 3, we say 10 minus 3, which is going to give me a 7. That means they're out of sequence. So that means it's going to take those two items and swap them. So the A represents the first number and the B represents the next number. And it does that for every one of these pairs. So it'll do 10 against 3, then it'll swap them, then it'll do 10 against 15. So 10 minus 15 will be negative. So in that case, that means it's sorted. And it'll just keep working its way down the line. So this is just to do that. Now, if we wanted to do a descending, we could simply reverse the B and the A. So let's go ahead and take this and pass this as a callback to our sort. And they should be sorted in ascending order. And as you can see, they are sorted now properly in ascending order, 3, 10, 15, 20. But what if we wanted to sort them in descending order? So I would just reverse these two. And so now, I have something wrong. Oh, why did I do that? Okay, B minus A. So let's go ahead and run it again. As you can see, they are now in descending order, 20, 15, 10, 3. But what if we wanted to make it more compliant with ES6? So we wouldn't necessarily want to do all this. So we can eliminate all that work. Now, you can actually declare your function right in line and say AB. Let's get rid of this. We're not going to need to compare there. And we could define the function without a name and just compare A minus B. Like this, right in line. And it should still work. As you can see, it still works. And so there's the descending order. So, okay, didn't do descending order. Did I not save it? B minus A. Oh, because I'm not returning anything, actually. So the first one probably didn't even work correctly. So let's see. Now it's in descending order because I have to tell it to return the value, and I didn't do that earlier. So anyway, a better way to do this with ES6 is just to use arrow functions. And arrow functions are basically like declaring the function in line, but it's a little bit shorter, it's a little bit nicer, because we don't need to declare, say that this is a function the arrow notation after the parentheses basically tells that this is an arrow function. And we don't need to, the return statement is either, and we don't need the semicolon or the curly braces. So it makes it a lot cleaner. So it's basically saying this is my function, takes two parameters, A and B, and it returns this value. Even though I don't have a return, it returns that. So now this should still work and it should sort in descending order. So it sorts in descending order. But what if our items were actually objects? Typically you're going to have in your production code, you're actually going to be comparing items that are not just plain numbers, they're actually objects. So this capability to have a callback gives us that. And the reason for that is because we can use properties of those objects. So for example, let's say that I had a couple of objects, and let's just say I had A equals Amy well, let's call it something more proper. Let's say name equals Amy and age equals 23. Now let's have another one of these objects. And let's make this a little bit cleaner. Let's bring it down here so we can see it. And let's say I had another one, and this one will be Robert. And the age will be 31. And let's create one more object. And let's just have John here. Age equals 55. Right? So let's say that first we wanted to just sort them on age. So we could do the same thing. We could take one of the primitives within it, and we could say age minus b dot age. Make sure I have all this correct because I'm seeing some squigglies here. So here are my objects. Name equals Robert, age equals 31, age. This seems right. Why doesn't it like this? Oh, yes. I don't know what I'm thinking. This is the proper notation for objects. Okay, I'm thinking C# for some reason. So I have that. So now everything looks right and it's sorting by age. So I should have it where it's in descending order. Let's make it in ascending order. So we should have, if it works correctly, we should have Amy because she's 23, then Robert because he's 31, and then finally John. So let's go ahead and do this and save it and run it. And as you can see, we have them all in descending order based on the actual age. And if we wanted them in descending order, of course, the same thing applies. B minus A, and then it's going to sort them in descending order. And as you can see, they are in descending order by age, 55, 31, 23. But a lot of times you're going to be comparing strings. So how would you do strings? Well, you would think that you could do something like this. And I think in some of the examples in the W3C website, I think I saw this, and it actually seems that it worked, and I couldn't understand why. But let's see. I'm not sure this will work. As you can see, this doesn't work. Well, it doesn't know what name minus name means, right? So what we have to do is we have to use the built-in compare function. For that. So now this is going to compare, it's the same thing, but since they're strings, it's comparing A.name against B.name. So now they should be sorted ascending order, so it should be Amy, John, and Robert. So let's go ahead and give, well, first let's save this. Let's go ahead and give this a run. Oh, I'm missing a parenthesis, okay. Go ahead and give it a run again. And as you can see, now they're sorted Amy, John, Robert. So what if we wanted to have them sorted in descending order? what if we had two that had, let's say, the same name but a different age? Say, for example, we had another Amy here. Uh-oh. Say that I had another Amy, but her age was, let's say, for example, 34. Well, if we leave it like this, right, it's going to compare by name. And let's go ahead and run this. So we have that. And let's go ahead and run this. And of course, we have Amy. And we have the two Amy's, but the two Amy's are now, Amy 34 comes before 23. What if we wanted to also, when the names are the same, like for example, sometimes you have first name and last name. What if we wanted to compare also on that? Well, that's where you get into something like this, where you actually put a little more logic in your arrow function. And you may actually want to maybe join the two. Maybe you say something like, let's say, for example, we did this. B plus age. And you compare against A dot name. Oh, I got it wrong. It should be B dot name plus age or something a little more interesting. Or maybe you want to compare just a different one. Maybe you want to join them. So let's say that we had B dot age. Let's see. I'm not even sure if this will work. I'm doing the wrong variable. So A dot age. Let's see if this works. And let's see. We are going in descending order. We don't want to go in descending order. We want to go in ascending order. But I have to change these two items. And another thing you may notice is that I am not returning. Since I added the curly braces, I actually now have to do a return here, because I have these curly braces for my lambda operation. Actually, I thought it was going to be a little bit more logic than this, but this should work. And so now we have, oh, it still didn't, it didn't take into account the, oh, yes it did. It should be A there. I have another logic error. So let's see. So now it has Amy 23 before 24. So you could have it where you have maybe last names or whatever, or maybe you're doing something more complex, which normally you shouldn't for comparisons, but maybe you're doing a little bit more. And that's the reason that I put this kind of out here, so that with the curly braces, and kind of show you what you would do if you actually have more logic and more meat in there. So anyway, if you like this video, go ahead and like it. If you don't like it, you know, place something in the comments. Let me know what you didn't like. If you do want more videos like this, please subscribe and you can get more. I plan to do more videos on the array functions. So this is just one of them, but there are more array functions and I like to cover those as well. So you won't miss a video. Go ahead and subscribe. Anyway, until next time, thanks for watching.